Let's teach counting right. Let's be sure that when we teach a child to count, we're doing it in a way that it's mathematically meaningful so that a child can not only count, but also understands the reason we count is to find out the size of a group and also understands how counting gets us this information. Hi, I'm Dr. Marty Epstein. I have a PhD in math education, and I know a lot about how little kids first learn math and what can go wrong. As adults, we take for granted how counting works to tell us information about a group's size. For us, it's easy. But that's hardly the case for a child. It's not easy. So let's break counting down into its pieces so we can think about teaching a child to count. And as we do that, we can be aware of all the pieces that need to come together for a child to count and to understand how counting works to give us information about a group's size. To find out the size of a group, we do this. 1, 2, 3. We know that the last number assigned to the group when we count tells us how many items are in the group. This idea that the last number in a count tells us the group size is called the Cardinal Principle. And it's not named after a bird. It's called the Cardinal Principle because the word cardinality in math refers to the idea of using a number to label a group's size. Understanding the Cardinal Principle is absolutely critical to early math. Unfortunately, children don't automatically learn or discover the Cardinal Principle when they learn to count. This happens for many reasons, including that the Cardinal Principle is not a simple single idea. Quite the opposite. The Cardinal Principle is a complex idea that's made up of several different math ideas. And some of these ideas get linked together first, and finally, when all these different ideas become interconnected and linked together, a child then understands the Cardinal Principle and then understands how counting works to tell us a group's size. So what are the key ideas that make up the Cardinal Principle? To understand the Cardinal Principle, a child needs to understand the idea of a group, that a group is a thing. And they need to understand that this idea of a group gets linked to the understanding that numbers are used to label the size of a group. If a child can subitize up to 4, it's a very strong indication that the child has these ideas and that they're linked together. Subitizing involves knowing the size of a group instantly without counting, and subitizing to 4 is the focus of videos 1 to 3 in this series. In addition, a child also needs to be able to recite the numbers they know consistently in ascending order from the lowest to the highest, starting with 1, and to be able to assign these numbers to items in a group using one-to-one correspondence. Like this: 1, 2, 3, 4. This skill takes time to acquire. There are lots of good YouTube videos out there to help. But before you help a child work on this one-to-one correspondence skill, make sure they master subitizing to 4 first. Reasons why this matters so much and help teaching a child to subitize are the focus of videos 1 to 3 in this series. So in summary, to be ready to learn the Cardinal Principle, there's a lot of work to be done first. A child already needs to have all this in place, these math ideas linked together this way. If they don't, they're just not ready to learn the Cardinal Principle, because learning the Cardinal Principle involves building this last important link, and we can't link together what isn't already there. But, and I hate to say this, even with all this in place, and this is a lot of work, these are complex ideas and difficult skills to develop. Getting to this point is a huge accomplishment, but we're not over the finish line yet. So even with all this in place, building this last link can be very challenging, and not all approaches work well to build it, if at all. However, the cells approach, I'll explain what that stands for in just a minute, has been shown to work well. When using the cells approach, only use it with small subitizable groups of 1 to 4 until a child truly understands the cardinal principle. So CELS stands for context, count, emphasize, label, link, show. First, I'll walk through an example of how it works all together, and then we'll backtrack and break it apart piece by piece. So now, let's pretend I'm talking to a child, and I'm trying to help that child learn the cardinal principle. I might say something like, you already know how many are in these groups just by looking, right? Let's check. And since we're not going to take this step to teach the cardinal principle until a child can confidently and consistently subitize to 4, the child should know the numbers that tell how many blocks are in each of these groups of blocks. Then I'd continue, but what about this group? I can't tell how many are in these groups. Most people can't. So what do we do? How do we figure it out? We can use something called counting to find out how many are in groups like this. Counting is so helpful. Let me show you how it works. We know there are 4 blocks in this group, right? We can also find out how many blocks are here by counting. Here's how. 1, 2, 3, 4. 4 blocks in this group of blocks. 4 blocks here. When we count, that last number is special. It tells us how many are in the entire group. Now, let's step back and pull apart what we just did and look at each piece separately. Remember, as mentioned earlier, to help a child learn the cardinal principle, use only small groups of 1 to 4 that a child can already instantly subitize. The first C in CELS stands for context. When a child is counting, we want them to always count in the context of finding out how many of something are in a group. In other words, we don't want to count just to count. If we say something like, let's count these blocks, 1, 2, 3, 4. We haven't given a child any mathematical context. We haven't given them a reason for counting. We've just asked them to say a number when they touch a block. Remember, they should be able to do this already, and just repeating this skill over and over, unfortunately, does not teach the cardinal principle. Instead, try something like this. We already know there are 4 blocks in this group, right? Well, it turns out that we can also find out how many blocks are in this group another way, by counting. Let's see how counting works to tell us how many blocks are in this group of blocks. So that was context. The second C in CELS stands for count. So now with the context set, we count the items in the group. 1, 2, 3. Let's pause here because the E in CELS stands for emphasize, and we need to talk about this before we get to the last item counted. It's super important to emphasize the last number in the count. Really emphasize it. This will call a child's attention to the fact that this number is special. In this example, 4 will be the last number in the count. So when we say 4, we really need to emphasize 4. I'll start the count again at once so we can see this emphasis in context of the other numbers. 1, 2, 3, 4. Now, the first L in CELS stands for label. So what this means is that we immediately say and emphasize 4 again, but this time we're saying and emphasizing 4 to label the entire group's size. So we're instantly repeating the number 4. There's no daylight between the 2 times we say the number 4, but the second time we say something like this, 4 blocks in this group of blocks. The second L in CELS stands for link. By immediately repeating and emphasizing the last number in the count, but now using the same emphasized number in a different way, a way that involves labeling the size of the whole group, we are helping a child link these 2 math ideas. That the last number in the count, which was 4 in this example, also tells us something else very important. It also tells us the group's size. And I've added an S at the end of cells to stress that showing the group size, not just talking about it, is helpful. Perhaps highlight the entire group or circle it with your finger. Let's put this all together again, starting with context. Maybe say something like this. Let's count this group to check how many blocks are in this group. 1, 2, 3, 4. 4 blocks in this group of blocks. 4 blocks here. When we count, that last number is special. It tells us how many are in the entire group. Of course, be sure to help a child use the cardinal principle with groups of 1, 2, 3, and 4, so a child can see that the cardinal principle works the same way, regardless of the size of the group. When a child truly understands the cardinal principle using these small subitizable groups, that's the signal to help them use their understanding of the cardinal principle to start to quantify larger groups. Wow, we've covered a lot of important ground. Let's stop here and summarize. The cardinal principle is foundational to math. Grown-ups often assume that teaching simple rote counting automatically teaches the cardinal principle, but it doesn't. It's important to explicitly teach the cardinal principle, but not all ways of teaching it work well, if at all. The cardinal principle is complex. It's made up of several different math ideas and links between them. Build these ideas and links first. When those pieces are in place, only then build this last important link. Remember, groups of 1 to 4 are uniquely important for first teaching the cardinal principle. Don't make the mistake of thinking that starting with bigger groups is better. It's not. In fact, it can make learning the cardinal principle much, much harder. Why? Because only with these small subitizable groups can a child both see the size of a given group and also see how counting works to tell that group's size. To build this last link to connect all the needed ideas, try the CELS approach. It stands for context, count, emphasize, label, link, show. This approach helps a child make a new cognitive link so they'll realize how counting gives us the number that tells us the size of the group. A final note. Understanding the cardinal principle is critical to understanding math. Well, why is that? If you think about it, what will a child think numbers represent if they've only been taught simple rote counting, so they have this bottom link below, but they're missing the other key pieces needed to understand the cardinal principle? They'll probably think numbers are simply the names we give things when we count, and they won't understand that numbers are used in math to label the size of groups. This difference matters, because if a child thinks numbers are simply the names we give things when we count, well, that's not the view of numbers that mathematics is based on. So with that exclusive view of numbers, a child simply won't be able to understand mathematics. For them, math will become a meaningless, frustrating exercise in memorization. Subitizing is a key input needed to learn the cardinal principle. That's why I designed Very Early Math Set 1 and the first 3 videos in this series to help a child learn to subitize. Then Very Early Math Set 2 covers the ideas reviewed in this video. These books are available on Amazon. There are links to the books and the videos here on this page, as well as on my Smiling Dog Math website. Thank you so much for joining me for Smiling Dog Math Video 4. Please share, like, and subscribe so lots of little kids can build a strong math foundation. If you happen to be curious about the research that informed the ideas in the Very Early Math series, well, here you go. Bye for now.